Hi, I'm Dr. G. Nagaraju, Assistant Professor, Department of CSE, AML, IoT and REI. Today, I can explain the tree traversal techniques. So, the meaning of the traversing means visiting each node in the tree is called as a traversing. Now, we have three ways to visiting the nodes. One is called as a pre-order traversal, second one is the in-order traversal, third one is the post-order traversal. So in the first one is here the pre-order traversal. So in the pre-order traversal, first we can visit the root node, then traversing the left subtree, then after that we can traverse the right subtree. So in that way we can visit each node in the tree. Then this type of traversing is called as a pre-order traversal. So first we want to visit the root node, then we can visit the left child. If the left child contains again the left child, okay, then we can visit here that child and so on. Here we can visit that left child's until here that node which do not containing any left children. Then after that visit the right children. Okay, then after that if the right children which contains the left childrens, then we have to visit that children until there are no left childrens. Okay, now in that way we can visit all the nodes in the given tree. Then this type of traversal is called as a pre-order traversal. So in the first one is in the pre-order traversal, first we visit the node, then we visit the left child, then we can visit the right child. Then this type of here traversing is called as a pre-order traversal. Means pre means before visiting that child, okay, we can visit that node. We can visit the parent node. Okay, so that's why here the name pre-order traversal. So in the given tree, now the pre-order traversal for this given tree is before visiting here the left children and the right children. So first of all we want to visit that node which is nothing but the D. Okay, so first of all we visit the A, and here the sequence is like this: A, then A contains the left children. So first after visiting that node we can move to here the left child B is there. Okay, now we can visit here that B. Again B contains here the node left children is there which is nothing but the D. Okay, again the D which contains the left children G. Okay, so there are no left children for G, again there are no right children for G. Then go back to parent of here this G. Parent of G is nothing but D. Okay, so after visiting the node left children, then only we can move to here the right children. So D right children is H. So H, okay, H has no left children. Okay, so that we can move to here its right children which is nothing but L. Okay, so L is a leaf node. Okay, then go back to parent of L. Okay, already we have visited here this node H and its right children. So go back to the parent of D which is nothing but D. Already we have visited the D and its left children and the right children. Then go back to parent of D which is nothing but B. So for this node B we have visited that node B and its left children. Okay, so till now we haven't visit here this right children. Okay, now go and visit the right children. Okay, which is nothing but E. Again E is a leaf node. Okay, so that go back to parent of E which is nothing but B. Now B node B is visited, again its left subtree nodes are visited and its right subtree nodes are also visited. Then go back to parent of, go back to here this node parent of B which is nothing but A. Now the node A is visited and its left subtree is also visited. Then we can move into here the right subtree of A. So the immediate right children of A is nothing but C. So visit that node C. Again C don't have that left children. Okay, then we can visit here the right children. okay, which is nothing but F. So visit that node F. Now F has one left children is there, and visit that left children I, and I is a leaf node, so go back to the parent of I, which is nothing but F. Again here visit the I right children, which is nothing but J. So J, then after that here J left children K is there, and go and visit that left children K. Again K is a leaf node, then go back to here the parent of K, again go back to parent of J, again go back to here the parent of F, again go back to parent of here C, which is nothing but A. Again now we have visited all the nodes in the given tree by using here this order. Now this order is called as a pre-order traversal. In the pre-order traversal, first visit the node itself, first visit the node, then visit the left children, then visit the right children, then this type of here traversing is called as a pre-order traversal. Okay, so for the given so for here the another tree, then the tree traversal, then here the pre-order traversal is, so first visit A has the left children B, then go and visit that one, so B has only one right children is there. Okay, so after visiting here the node left children, then visit the right children, that is nothing but here D. Okay, so D has no children, then go back to here this D, which is nothing but B, again go back to B parent node, which is nothing but A. Now we have visited that A and its left subtree elements. Okay, then move to here the right subtree. Okay, in that immediate right children is C has only one left children, which is nothing but E. Okay, and visit here that C has no left children, again C has only one right children. Okay, go and visit here that right children, and see F has only one left children is there, that is nothing but G. Okay, again G has here the left children, which is nothing but H. Okay, so after visiting here the node and the left children, then only we can visit the right children, that is nothing but I. So this is nothing but the pre-order traversal of here the given tree B. So this is here one of the tree traversal techniques. Then the next one is in-order traversal. So in the in-order traversal, first we visit the left subtree, then we visit the node, then we visit the right subtree. Then that type of traversing technique is called as a in-order traversal. So in the given in-order traversal, so first we visit the left subtree, okay, then we visit the node, then after that we visit the right subtree, then that type of traversing is called as a in-order traversal. Okay, so here the in-order traversal and the algorithm for that in-order traversal is, first we want to visit the left children, then we visit the node, then we visit the right children. See, so before visiting here the node A, so first of all we visit the left children, so B is there. Again before visiting here this node B, so first of all we want to visit the left children, that is nothing but E. And before visiting here this node D, first of all we want to visit here the left children, that is nothing but G. So here the G, first we visit the node G, then only we can go back to its parent node, that G parent node is D, then visit the D. First visit the left child, then node, then only we can visit the right children. So here the right children is H is there. Okay, so suppose if H contains any left subtree, so that we can visit that node first, but anyway here there is no left children for this H, so that we can visit H. Okay, then after that visit the right subtree, that is nothing but L. Okay, then L is a here leaf node, that means there are no nodes are there, so that go back to parent of here this L, which is nothing but H, again go back to parent of H, which is nothing but D. Then here after here the D and its left subtree, again the right subtree nodes are visited, then go back to the parent of D, which is nothing but B, and visit that node B. Okay, we can visit a node, okay, only after visiting here the left subtree nodes. Means we can visit B only after visiting here the left subtree nodes. So already here the left subtree nodes are visited. okay, then only we can visit here the node B. Then after that we go to here the right subtree of B, which is nothing but E, and E is a leaf node. Okay, so go back to parent of E, which is nothing but B. Again go back to parent of here B, which is nothing but A. Now visit A only if its left subtree elements are visited. Okay, now here the left subtree of here this A are visited. Okay, so that now visit that node A. Then move to here the C. Okay, so the node C is visited only here the left subtree, or here the left child is already visited, but anyway here the C which do not contain or which do not have any left children. Okay, so that visit that node C. Then after that go to here the right subtree, which is nothing but F. So F is visited. Okay, we can visit F only after visiting here the left child. So F has the left child I. So first to go to here that left child and visit that left child I, then only we can visit here this F. Then after F here go to here the right subtree of J. Now the J node will be visited only after visiting its left child. Okay, so here the left child of J is K. Okay, so after visiting the K, then visit J. So this is nothing but in order traversal. By using that in order traversal, okay, we can visit here these nodes, and this is the given in order traversal order. So for this one here, for this tree, okay, we get here the first to visit the D B. Okay, then after that D, then after that A, then after that here E. Okay, then after that here after E, then here after E we can visit here this H, then G, I, F and C. So this is the here the given in order traversals for the given tree B. Now the last one is the post order traversal. So here you have to remember one important thing, that is here suppose if the given tree is a binary search tree. So the property of a binary search tree is the left side values are less than the parent node and the right side values are greater than the parent node. So that for the in order traversal for the binary search tree always gives the elements are in ascending order. So let us take here 10, 8, 4, 12, then let us assume 11 is there, 14 is there. Suppose if we apply the in order traversal, okay, then here the order is now the elements are in the ascending order. So directly we can write here the order is 4, 8 to 10, 11, 12 and 14. Remember here this is very important thing which is related to the binary search tree and in order traversal. Suppose if the given tree is a binary search tree and if we apply the in order traversal, then the elements are in the, then here the traversal order is, okay, the elements are in the ascending order. Now coming to here the post order traversal. In the post order traversal, first to visit the left subtree. Okay, then after visiting that left subtree, visit the right subtree. So after visiting here that left subtree and the right subtree, then only visit here that parent node. So that's why it is called as a post order. Means before visiting here the parent, first we have to visit the left children and the right children, then only we can visit the parent node. So this type of traversal is called as a post order traversal. Post means here now we are postponing here the visiting of that parent node. Okay, after visiting here the children, the left children as well as the right children. So that's why here the traversal name is post order traversal. So in the post order traversal, first visit the left subtree, then visit the right subtree, then visit the root node. Then this type of traversal technique is called as a post order traversal. So in the given algorithm here, the post order traversal is first visit the left children, then visit the right child, then only visit the parent node. So the post order traversal for the given tree is, so first of all we have to visit this. So we can visit A only after visiting B and C. So we can visit B only after visiting D and E, and we can visit D only after visiting G and H. So first of all, come to left node, left children. Again here this node which do not containing any left children and the right children. So that first visit the G. Then after that go back to parent node, and the parent node will be visited only after visiting the left children and right children. So just now we have visited that left children and the right children nodes are not yet visited. So go to here that right subtree. Now H, so H is visited, the node H is visited only after visiting the left children and the right children. So here there is no left children for H, it has only one right children is there. So first visit that right children L, okay, then only we can visit H. Okay, then now after H go back to parent node which is nothing but D. So the node D is, the parent node D is visited only after visiting its left subtree elements and the right subtree elements. Now we have visited the left subtree elements G and the right subtree elements H and L. Now we can visit the parent node D. Then go back to parent of D which is nothing but B. Now the node B is visited only after visiting the left children and the right children. Anyway that left subtree is visited but the right children is not yet visited. So first to visit that right children E, okay, because here the right children it is a leaf node, so that's why visit that right children. Then go back to the parent node which is nothing but B. Now this B is left to subtree elements and the right subtree elements are visited, so that visit that parent node B. Then go back to parent node which is nothing but A. Now A is visited only after visiting here the left subtree as well as the right subtree elements. So till now we have visited the left subtree elements and not yet visited here the right subtree element. So first go to here the right subtree, and the immediate right children is C. Now C is visited only after visiting the left and right children, so that first to move to here right children F, and now we can visit that F only visiting after the left subtree and the right subtree. So first of all go to the left subtree which is nothing but I. Then after I, okay, I it is a leaf node, so go back to the parent of I which is nothing but F. Now F is visiting, we can visit F only after visiting here the left subtree and the right subtree. Now here the right subtree elements are not yet visited, so go back to here that right subtree element which is nothing but J. This J will be visited only after visiting the left subtree as well as the right subtree. So first go to here the left subtree and visit that node K. Okay, then after that go to here the parent of this K which is nothing but J. Now we can visit J because here the J has only one left children is there, that is already visited, and J has no right children. Okay, so that visit J. Then go back to here the parent of J which is nothing but F. Now F left side elements, left children, left subtree elements and the right subtree elements are already visited, so visit that F. Now go back to parent of F which is nothing but C. C has no left children and C has right subtree is there, and that right subtree elements are already visited. Then visit here that right subtree which is nothing but C. Okay, then after that go back to parent of C which is nothing but A. Now A's left subtree elements and the right subtree elements are visited. Then visit here this A. Now this order, so this type of visiting it is called as a post order traversal. So here the post order traversal for the tree B is like this. So here we have D, first visit the D, then B, then H, then I, then G, then F, then E, then C, and at the last A. And here we have to remember two important things. Okay, now in that one here the first important one is here. So in the pre-order traversal, so in the pre-order traversal the first element is always the root element. In the pre-order traversal the first element is always the root node, and the second one is in the post order traversal, in the post order traversal, always here the last element is the root node. Okay, you have to remember these two things. In the pre-order traversal, always here the first element is the root node, and in the post-order traversal, always here the last element it is the root node. This is about the in-order, pre-order, and the post-order traversals. Next, we want to construct a binary tree for the given pre-order and in-order traversal techniques. So already I told, in the pre-order traversal, the first node is always the root node. So in the given diagram here, in the given thing, that G is a root node. Then after that, locate here that G in the in-order traversal. So here we have G is there. So all these elements are left subtree of this G, and all these elements are the right subtree of this G. Then after that, so first of all, we have to construct the left subtree. Now in that left subtree, the immediate left children of here this G is B, because here now the B is located in the in-order traversal, that B is located at the left side of G. Okay, so here B is there, so that the immediate left children of here this G is B. Now B is completed. Now B. So B again locate here that B in order traversal. So B has only one left children, which is nothing but Q. Again here this K, C, F, A are the right children of here this B. Now Q is also completed. Now among these K, C, F and A, and the immediate right children of here this B is A, because here A is there. So here the right children of B is A. Again locate A in order traversal. So now A has no right children, and A has only here the left children, which are K, C and F. So we can find here the immediate left children of here that A is C. So immediate left children of A is C. Again locate C in order traversal, and C has one left children, because here the K position with respect to C is at the left side, and here the F position with respect to C is at the right side. So C has one left children, which is K, and C has one right children, which is nothing but F. So K and F are completed. So K and F are completed. Okay, so till now we have constructed the left subtree of this G. Now all these elements P, D, E, R, H are belongs to the right subtree of here this G, because here all these elements in the in-order traversal, all these elements are at the right side of here this G. So from this one, first of all, we have to find the immediate right children of G. So the immediate right children of G is the next node. So here the P only. P is immediate right children of G. Again locate that P. Okay, so P has no left side elements, means P has no left children, and P has here the 4 right children are there. Okay, so that, and E, D, H are the right side or right subtree elements of P. Then in that one here we can find the immediate right children of here this P. So for that one, go to here the pre-order traversal. In the pre-order traversal, the next element is D. So the D is nothing but the immediate right children of P. Again locate here that D in the in-order traversal. Okay, so the left side elements of the D has only one, which is nothing but E, and D has 2 right side elements that are H and R. So D has one left child, which is E, and D has 2 right children, they are E and H and R. So first D has only one left child, which is nothing but E, and D has 2 right children, which are H and R. So among that, okay, So which one will come first means here. So for that one we can go to the pre-order traversal. In the pre-order traversal, R will come first, so that R, it is the immediate right children of D. Okay, so locate R in here the in-order traversal, and the position of here the H with respect to R is, that is at the H is at the left side of R, so that H is the left subtree of R. So in this way we can construct the binary tree by using here the given in-order and the pre-order traversals. And similarly we can also construct the binary tree by using here the in-order and the post-order traversals. In-order and post-order traversals. Okay, but in some cases we may get the ambiguity for constructing the binary tree for the given traversals like post-order traversal and the pre-order traversals. Suppose here in the problem it is specified constructing the binary tree by using the pre-order and post-order traversal, then in that case here we may get ambiguity, or we may get here more than one tree. Okay, so that we can construct only unique tree either using the pre-order and the in-order traversals, or we can get only one unique tree by using here the post-order and the in-order traversal. So here this in-order is mandatory for both the pre-order and post-order. Okay, so in this way we can construct the binary tree. So here in this case the pre-order and post-order is given. So here in this case here we may get more than one tree. So there is an ambiguity. So which one is a correct tree? So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.